this. Yeah, so let's talk about managing database storage structures in Oracle database. And when we talk about managing database storage structures, we all know that database storage structures are actually subdivided into two sections. We have the logical database storage structures, or let me call it DB structures. And on the other hand, we have the physical DB structures. So what happens is the difference between the two is based on the way it's being created. For example, the logical database storage structures, these are structures that are created by the Oracle database, but they are not visible to the operating system. So in this case, if I can just wrap it up just like this, you can just try give like a glimpse to what is happening. For this one, you can say are created by Oracle DB. Okay. Oracle DB, and are not seen or are not visible to, are not visible to the operating system. Okay, so so when we talk about by the operating system, or in other words, by the OS, we all know the OS. So these are created, the logical database storage structures are created by Oracle database and are not visible, for this case, are not visible to the operating system. They are not visible to the operating system. Now, this means what? You see, for logical database storage structures, we need to have a physical database structure for them to exist. Okay, let me share. So I think entire screen. Now, is it visible now? Okay, so for this case, we are talking about the logical database storage structures. And we've said that they are actually created by the Oracle database, and they are not visible to the operating system. Now, this means that it's only through the physical database storage structures that we can end up having the logical database storage structures. And the logical database storage structures usually stores database objects. Storage structures usually stores the database objects, such as tables, such as views. And this is the reason why we have them inside the physical database storage structures. Okay, so so that I can still share on that note. So what happens is, so when we talk about the logical database storage structures and the physical database storage structures, so the difference here comes by how they are created. So when we talk about the physical database storage structures, for this case, it's actually, or there are structures that are basically created by the operating system. So once you have the operating system, they are created, and that is the physical database storage structures. So even for users, so for this case, they are created by the OS and are visible. Of course, they are not again visible to the other side, but in this case, we can just say they are only created by the operating system. Why? Because they sit on top of an operating system, and that fills the gap between the Oracle database and the operating system for storage purposes. So if every data or any data has to be captured from the database, it has to go directly to the database storage structures, which is actually the physical database storage structures. And for example, here we have, for example, the data file. We have the data file. For logical storage structures, the main here is actually the table space. So here we can talk about the table space. But when we talk about the database storage structures, we are not actually talking about the table space. We are talking about the data file, so that through the data file, we are able to talk about the table space. Because the only way for you to create a data file is through the creation of a table space. Even if the table space exists, you need to create the data file as you do what? As you connect to that existing table space. So when we talk about of course, the database storage structures in general, we can actually subdivide into the logical database storage structures and the physical database storage structures. We all know that when we talk about the database storage structures, even in terms of their separation or the subdivision, when we talk about the logical storage structures, we all know that, for example, we have the database, and below the database, we have the table space. Below the table space, we have the segments. Below the segments, we have something called the extent, and then we have the data block. Now, all this means what? All this means this is a section, or all this represents the logical database storage structures. So we've only captured the table space because on this other side, they are all connected to what? To the data file. So if I'm to draw something like a chart, this side will represent the logical database storage structures, and this other side will represent the physical database storage structure. So here it means that because I'm actually using like a notepad and I may not be able to draw, we can say that a table space, one or more table spaces makes up a database. One or more segments makes up a table space. One or more extents makes up a segment. One or more data blocks makes up extent. So you will find that we have the many side. For whatever thing that is below the other, that actually amounts to the many side. Now, the database storage structures that are very important to us. Of course, even these ones are important, but we will end up talking about the segment, extent, and data block when we will talk about, we have a chapter called space management, and we will end up now exploring more on what segments, how do we adjust the segments, and how do we adjust the extents, and also how do we find the data blocks. But in this case, I want us to talk about the table space and the data file. Of course, we are referring it to the data file so that you can come later and talk about the table space. Now, opening here. Okay, let me see. Okay, so the Oracle or the database storage structures, which are actually the major database storage structures we talked about when we were referring it to the Oracle database architecture, are these. So the main ones we're going to concentrate is, number one, we want to talk about the control file. Number two, we want to talk about the data file. Or okay. Number three, we need to talk about the online redo lock file. Or you can also refer it to us, instead of having like online, you can just call it redo lock file. It's just the same thing. So these are the major ones. These are the major database storage structures. And of course, we also have the minor ones. If I can just mention, we have, for example, the parameter file, which comprises of the SV file and P file. And these parameter files always tell us more about how the database is configured at startup. You see, the way you want the database to be up and running depends on whether you're using the SP file or P file. So, and another minor is, for example, the backup files. So these are basically meant to capture backup files or backed up. Whenever backup is being done, there are files to be captured there. We also have like the trace files. We also have the alert log files. Of course, we also have like the password files. So all this will interact with them just to know how do we probably modify or manipulate the password files, and of course the parameter files and the rest. But in this case, these are also part of the database storage structures, but they are the minor ones. They are the minor ones. Now, so I want us to talk about this. So when talking about the three, it's so broad, especially when it comes to the data file, because we need to extend it to understand the table spaces. And of course, we know the different categories of table spaces that we have. So I think, first of all, we're going to cover the control file and the redo log file, and then, of course, see how we can manage the data file. So number one here, we need to talk about the control file. Now, in this case, a control file is a critical file to the database. Is a critical file to the database. Is a critical file to the database. Why critical? Why critical file? Now, I know that we will have a chapter, which is, a unit which is based on backups and recovery, and we will tend to understand how do we recover different database files. And these files, the recovery part of these files will now be based on whether the file is critical file or whether the file is non-critical file. So we will actually separate the files with whether a file is a critical or non-critical. When we talk about a critical a critical file, it means that the file is mandatory for the database to function. Non-critical files, these are files that are optional. It's not a must for them to be there for the database to function. They can be there, they cannot be there. The database will always be up and running. But for critical files, it is a requirement that these files should always be there. So control file is a critical file to the database, and this is responsible for ensuring that the database is available. Is responsible for ensuring that the database or the DB is available. So when we talk about availability of the database, this means that, you see, as users, if a user wants to interact with the database, he has to log in as a normal user. That after the super user's credentials have been entered. So that connectivity is being guaranteed by the control file. Now, another point with the control file is that the control file, by default, let's say by default, we have, by default, the control file has been multiplexed. That means, multiplexed into 2 copies, let's say into 2 copies, sometimes like 3 copies of the same identity, Now, when I talk about multiplexing, this is like multiplying. You see, we have a single control file. So if we do the multiplexing, it means that we are performing or we are reproducing it to have multiple copies. So by default, we always end up having 2 copies of the same identity. This does not mean that the 2 control files have different contents, no. Both of them have the same size, the same content, and they perform the same purpose. So what happens is, the reason why we are multiplexing or having the 2 copies of the same identity or the same control file is to prevent, you see, to prevent against for this case, not even against data loss, but against prevent against database failure. So this means that if at all you lose a control file, for example, we have this. For example, we have like control01.ctl, and we also have control02.ctl. So this is how you can identify. This is how you can identify the two control files. So we have control01.ctl and we have control02.ctl. Now I will also show you the parameter on how we can do that. So this means that for you to prevent or to ensure that, or to guarantee the availability of the database to any normal user or to any database users, this means that the control file by default is always multiplexed into 1 and 2. But at some point, you may end up having only one. So having only one control file does not deter you from using the database. But you see, the database is at risk because what happens if this file fails? You see, if this file fails, then you do not have any other copy of the same control file. So it is always advisable that you multiplex. That means you reproduce a copy of this and then you rename it as 2. That is only when probably either of these has failed. If 02 has failed or has been lost, then you have to do what? You have to bring 01 or to create 01. Now, if 02 is lost, then of course you're supposed to create 02 from what? From 01. Now, how do you view this? You see, how do you know the number of control files that you have? And of course, how do you know the location of these control files? Because you see, getting into a folder, trying to open and closing as you maneuver through, trying to look for these control files may be a little bit difficult for you. So the only thing you can do is just to execute a parameter file. So you can just type show parameter control. And by so doing, it will give you the two locations, or it will give you all the available control files and plus the location. So just to know that control file is a very important file. It is responsible for ensuring that the database is available. And of course, it's actually the control file that stores all the information regarding the database, including the data dictionary, the database name, when the database was created. Everything has to be executed, or everything has to start from the control file. So it acts as the engine, the starting engine of the entire database. So practically, let us do this and see what happens. So I'm going to start or just open my SQL or SQL Plus. So for this one, of course, I'm already connected as a super user. So I want to type show parameter control. And for this case, if you look at this, let me just reduce the size for my case. Now you can see that we have this parameter, show parameter control. Now here we have 3 parameters. We have control underscore file underscore record underscore keep time. We have the control files, and this is what I want us to talk about. So if you look at this, you can see that on this other side, we have a path. And this path tells me a lot about the location of my control file, about the name of my control file. And if you look at it keenly, you can see that we have a name there, control01.ctl. So for my case, I only have a single control file. So, and this is 01. So I don't know, probably the other one got failed or just lost. And I think later I will be required to recreate the 02 or another, or to reproduce another control file from the first one. And this is important. This is important just in case of my database failing, then at least I have something to be catered for. So what happens is, for your case, I think you can tune, and I think you're able to see two, control 01, comma, and then give you another path for control 02. So let me prove this one, whether we have only a single control file. So this is my path. For your path is also different, or it can be as mine. So what I will do, I'll just right click and copy, and then I will open a folder, and then I will just click there and paste. So if I can just do that and press enter, now you can see that I have a what? I have only a single control file. I have only a single control file. So this means that I need to recreate another one. And it's not hard even to recreate the second one. You see, if I need to recreate the second one, what I need to do, I need to copy this. I need to copy this. It's so direct because we have like duplicate. It's actually the same information, but duplicate. So I need only to copy control 01, and then I can move to a different folder. Let me go back one step to Aura data. Let me paste it here. And then let me rename it. This is the only way you can do it. Like just rename it and call it what? 2. And then now cut it again and bring it one more step. That means we need to get to, okay, ORCL. And then I will paste it here again. So for this one, I am sure now that I have now the control 01 and control 02. So what happens is, these are control files. If you look at that ends with 01, like control 1, 01, control 02. These are referred to as the control files. So by default, you end up having only the 2 control files. Now, if you look at this, if I want to, just to highlight you on what we have here, we have this that like redo 01, redo 02, and redo 03. These are referred to as the online redo log files, or the redo log files. Now, coming down on this part, these are referred to as the data files. These are data files. So a data file will always have an extension .dbf, have an extension .dbf, have an extension .dbf. So we are going to have a look at the control file, and then from there, we can end up talking about the redo log files, and then later we'll also talk about the data files. So it's very important for you to understand the concept of what is a control file, why is it a requirement for us to have within the database, and then what is the, let's say, what is the reason why we have it in the first place, and of course, why do we have the multiplexing of these control files? So just have this name, the multiplexing, multiplexed. This is to reproduce a copy of the actual file. And the only way you can look at probably to check your control files, this is the only way you can do. And you see, this one, the system will actually pick it automatically. Whether you have control 01 and 2, the system will always identify one of them and use it. It can end up using 01 this time, then probably the next time you start your database, it will end up using control 02, because these 2 files are of the same size, they are of the same contents, so it's just the same file that we have. So that is about the control file. So for the practicality of it, you see what happens if a control file is lost. How do we recover the database? So for that, it's going to come in the near future, because we have a chapter on, a unit on backup and recovery. And we will be able to concentrate more on why or how, what happens if the control file is lost, or what happens if a critical file is lost in the first place, what error are we going to encounter, and then of course, how do we recover the database from this? So for this case, it's just to mention, just to highlight. Now, that brings us to the online redo log file. Now, for online redo log files, these are very important files to the database. They are very important. Redo files or online redo log files, this contains, let me say, contains redo log data. You see, contains redo log data that are used to prevent data loss. You see, to prevent data loss. So in this case, if you still remember the Oracle database architecture, we had the database buffer cache, which always captures the changes that happen within the database. And then the change is duplicated and pushed to the redo log buffer. And once they are in the, okay. So what happens is, share, don't worry about that network issue. So for online or for redo log data, these redo log data are always used. You see, as long as it prevents data loss, redo data are used for instance recovery. They are used for instance recovery. So they are very important. Now, remember, we have the differences between undo data and redo data. And I think that is something we'll talk about in the next lesson, managing undo data, so that we can see the differences between redo data and undo data. But redo data here are important, especially when it comes to instance recovery. So this is the copy of the pre-modified data within the data file. So redo data are used for instance recovery, and it's actually the online redo log file that contains this redo log data. And once we have this redo log data, they end up preventing data loss, because if I lose my data, then I can be able to use the redo data to recover the instance, and my data will be up and running. So just know that this is another database storage structures, which is actually the major database storage structures, and it's important. Now, how do we view the online redo log file? Now, again, talking about multiplexing. So redo data is a multiplexed data. Multiplexed data. Why? Multiplexed data. Why? Because we have more than one copy. So this one means that, you see, as long as the multiplexed data, we also end up having called the redo data groups. You see, we have redo data groups. And these groups can have, you see, redo data groups have or can have one or many redo data or redo logs, which becomes the members, or which qualify to become a member, or which are members of these groups, members of these groups. So in this case, you'll find that maximally, by default, we have three groups. By default, we have 3 groups. And these groups are actually denoted. So denoted by the group. We have something called the group hash, but in this case, we have group 1, group 2, and group 3. Now, each group one can have by default, you see, group one by default has only one redo log. Group two by default has one redo log. Group three by default has one redo log. But you can decide that in group one, you want to have more than one redo log file. So by that, I will show you how we can do what? How we can create other redo logs. So what happens is, after that, how do we view this? So for us to view this, we need to have this particular file, which is actually a dynamic performance view table. It's actually called the v $log. So if you describe v $log, you will end up getting what? You will end up getting all the columns, or necessarily all the columns that are there. For example, I want to take you through on the practical part. So what happens is, if you describe v $log, look at that. We have all these. We have all these columns. Remember, this is actually the structure. It's actually the structure of this dynamic performance view table. And I want us to select some view so that we can prove the point here. First of all, I want us to select the group hash. So I will just copy that and then paste, comma. I want us to select members, comma. I want us to select, okay, let's see the size, like bits. And you can also have the status, no problem, from v $log. Look at that. So here we are talking about the groups. And the groups, by default, there are three groups, which based on the information given here, we are, right? So we have three, 1, 2, and 3 group. So these are act as the name, the group identifier, because these groups have to be unique. Now, from this point, you can see that they are members. We have one member here, and also we have one member here, which again proves the point that for every group by default, we have one member. So these members represent, represents, let me see whether we have the names. Okay. So these groups, where was I? Okay. So what have I done? Okay. So these groups means what? You see, if I go back to this point, you can see that we have what? We have redo 01, redo 02, redo 03. So it means that redo 01 is in group 1, redo 02 is in group 2, redo 03 is in group 3. So this means that based on the information here, you can see that redo 01 is here. That is one member. So, and now the size of that redo log in terms of the data within. So it's being calculated here in terms of bits, but we can also convert it into probably MB or GB. We can still do that. And then of course, look at the status. So we have the status of the redo log number 1, and the status is current. So this status means that the redo log number 1 is active to capture any activity happening within the database. Now the rest are inactive. Now, because the status for the rest are inactive, this does not mean that they are dead or they are not functioning. No, it's only that when redo 01 fails, then the redo 02 becomes active. And also once the first one, the second one becomes inactive or fails, then we also have the third what? We also have the third redo log. So here we are talking about the multiplexing of redo log files. And it's very important because we might end up performing a bulk update or bulk execution of data. And you see, that will not you see, only having a single redo log file will not allow or will not be able to capture all the redo log data coming from the bulk statement. So what happens is, if we have as many as we probably could, then you see it becomes now easy for this redo log file to handle the redo data coming from the bulk statement. So now I want to show you one more time, one thing. And again, we will also talk about this later, especially when we'll get into backup and recovery. We will also end up having that. But the only thing I want to show you is how can I add, assume that I want to add another redo log. You see, for example, redo 01, redo 02, redo 03. You see, what happens if I want to add more? So if I want to add, let's say 04 and 05, the first thing that should come into my mind is that, which group am I adding? Am I adding to group 1? Am I adding to group 2? Or am I adding to group 3? So the first thing first is that we need to add these redo logs by pointing to this direction. We have to point them to this location. So what happens is we have to copy the path. We have to copy the path and look how these redo logs have been, their names appear. So it is redo 01, redo 02, redo 03. So what happens is I'm going to copy the path because I want it to go to this path. Still, for your case, you can decide that you want to put a desktop or whichever, it's not restricted. And then we need to do something called the alter database, add log file, and then talk about what? Members. And then paste the path. And then here I want to put redo 04 to where? To group. So let me put it to group 1. You see, alter database, add log file, members, and then I'm giving the path. And then this is the name I am adding. You see, the last redo we had is 03. So I'm adding 004. And then press enter. So here we are talking, So it's a member missing. Okay, so you can see this point in Mexicana. So I have to separate that to group 1. Yeah. So now database altered. So remember, I have come up with another redo log. That means I am performing something called I am actually multiplexing the redo log. So I am coming up with the fourth one, which is redo 04 to which group? To group 1. Now let's prove this point. Let me have again, select group this, let me press enter. Look now at this one. I have added to group 1 and it is redo 04. Initially we had in group 1 to look on only one member. So in this case, I have increased the number of members or members to 2. If I repeat again, look at this one. This is 1. Let me add a member there. So this one I want it to put to 2. And then let me put it to 5. Okay, 5. Press enter. Database altered. Now let me increase the member in group 3. Group 3, and then let me add it to 6. Database altered. Now, if I come back now and select groups hash, press enter. Now you can see now that in group 1, we have 2 members. In group 2, we have 2 members. In group 3, we have 2 members. So here we have added or multiplexed the redo log files. Now, what happens if I go back to the folder? Look at that. I have what? I have increased the number of redo locks. And no even if you want to give like 1,000 redo locks, it always depends on the size of your file or their disk, I mean. And that again gives you a platform on how broad or how easy your redo lock are going to be, I mean the redo data are going to be captured. So for this case, you can see now that it is very easy for us to manipulate the online redo log files by multiplexing, at the same time also to identify the control files by using the parameters. And yeah, so if we're able to differentiate between the groups and the members in terms of understanding the online redo log files, then the better. Now, so those are the two database storage structures. In terms of their practicality, that is the point we can end up, because the next thing or the next practical after that is now to understand what happens if all the redo log files are lost. What happens if all the redo log files are not working? So will we are we able to solve the database, or are we able to recover the database from such failures? So that is actually like an intense recovery process, but we're going to have it step by step. We're going to have it step by step, and we will see it fully. Now, that brings us to another one, which is actually data files, and it is a broad one. And for that, I don't know, I just want us to probably end it there for today, so that we can pick it from there tomorrow on the table spaces and the data files, because a broad one. And I wish probably by tomorrow tutakuwa sawa in terms of OMA and all that. Now, any questions so far from your side?